Okay, in this video we're going to have a look at how to analyse information from a rate of reaction experiment. And what we've got here is a graph showing the data that has been collected. So you can see we've got two measurements on the graph. We've recorded the time that it takes for this reaction to proceed, and then here we've measured the volume of gas that reaction has produced, and that data has been plotted to give us this characteristic shape for a rate of reaction experiment. In order to calculate the rate of reaction, then what we need to do is draw a tangent on this line at the point that we want to calculate the rate for. Okay, what I'm going to do is I'm going to calculate the initial rate. So initial is at the start of the experiment. So to do that, we draw ourselves a tangent to the curve that we've got for the experiment. So I'm going to try and do this on here. Okay, and hopefully I've done a different colour. We can therefore see the tangent at the beginning of this experiment for this curve. What I'm going to do now is turn this into a triangle. I'm going to use the graph to help me to do that. So my triangle shape here comes down from that point there. And you can see here now, using the tangent, I've got myself the shape of a triangle. I'm going to use this now to calculate the rate of reaction. So to calculate the rate of reaction, I need to find the gradient of this particular tangent that I've drawn. So on here, I'm going to write down that the gradient equals, and to calculate the gradient of any triangle, we take the difference in the y-axis. So it's going to be difference in y-axis, and we divide it by the difference in the x-axis. So that's this bottom axis here, and we say divided by the difference in x-axis. Now for us, the y-axis is the volume of the gas, and the x-axis is the time. So this actually becomes, for us, the change in the volume, difference in the volume, divided by the change in the time. So if I look at my graph for a second, let's work on the change in the y, the change in the volume. So here it starts off at 0 and it ends up at a value of 20 centimeters cubed. So the difference in the volume in that time is going to be 20. Let's look at the change for time. So in that same time frame, what has the time measurement done? The time measurement has gone from 0 up to 10. So the change in that data is a value of 10. 20 divided by 10 is 2. Now remember, volume here is measured in centimeters cubed. Time is measured in seconds, so it's centimeters cubed per second. So this means at the beginning of this experiment, every second 2 centimeters of gas was being produced by this reaction. Okay, so that's the rate of reaction, the speed of this reaction at this point, 2 centimeters of gas being produced every second. And you can probably tell, it's worth just doing a very quick comparison. If I was to pick a different point, let's say I was to pick, say, here on the graph, if I was to draw another tangent here, then you can see, if we were asked to calculate it at 20 seconds, where that dot is, you can see what I would need to do is draw out my triangle and make my triangle complete here, and then you'd find the tangent at this point, and you can see quite clearly that the tangent here is not going to be as steep as this one. Therefore the value for this is going to be less, and we'd expect the value to be less because as the reaction proceeds, as time goes on, there are less particles, less chance of collisions, and the reaction starts to slow down. Okay, that's how to calculate rate. Good luck, have a go at some questions, get some confidence with that.